This is Mr. Rock, and welcome to my video about the Pythagorean Theorem. Here I am, not wearing a mask. How do I look? The first thing that's important to know about the Pythagorean Theorem is that the Pythagorean Theorem can only be used with triangles that are right. And usually you can always recognize a right triangle because it has a little square in the corner. The Pythagorean theorem cannot be used for acute triangles, and it cannot be used for obtuse triangles. The Pythagorean theorem can only be used with right triangles. This is a right triangle. How do I know it's a right triangle? Because of this box that's right here. This tells me that the triangle is right. Now this right triangle has parts. The first two parts include the legs that make the 90-degree angle, traditionally named A and B. So when I look at this triangle, I look for the 90-degree angle, which is right here. These legs, these sides right here, let's change the color. This side right here, that makes part of the 90-degree angle. And this side right here, that makes the other part of the 90-degree angle. So these two sides that are red, these are called legs, and we traditionally name them with the letters A and B. The other side that slanted, this side right here, that slanted, that is always going to be the longest side of a right triangle. And this side has a special name. It's called the hypotenuse. And this side always has a traditional name. We usually call this side C. So those are the parts of a right triangle. So finally, we are ready to announce the Pythagorean Theorem. Here it is. It says, if the triangle is right, and I know my triangle is right. Here is the symbol indicating that it's a right triangle. So if the triangle is right, with sides A and B, remember, here is side A, here is side B. These two sides make the 90-degree angle. So these two sides are called the legs. Those are the legs. So if the triangle is right with sides A and B, and then we have a third side, the hypotenuse C. Here's our third side, this hypotenuse. Remember, it's the side that is slanted and always the longest side. So if the triangle is right with sides A, B, and C, then A squared plus B squared equals C squared. That is the Pythagorean theorem. So here is a triangle that is right, a triangle that has one leg equal to 3 units, another leg equal to 4 units, and a hypotenuse equal to 5 units. And what I want to show you is that the Pythagorean theorem actually works. So I'm going to write down the Pythagorean theorem. Well, first of all, I'm going to write down some information. I'm going to write down that A is equal to 3, B is equal to 4, and c is equal to 5. And I'm going to write down the Pythagorean theorem. A squared plus b squared equals c squared. And I want to show you that the Pythagorean theorem actually works by plugging these numbers into the equation. So let's see, one leg is 3, the other leg is 4, and the hypotenuse is 5. 3 to the second power equals 9, 4 to the second power is 16, 5 to the second power is 25, 9 plus 16 is 25, and that equals 25. So you can see when we put these numbers in to the Pythagorean theorem, it works. Both sides are equal to the same number. 25 is 25. Numbers 3, 4, and 5. These numbers right here, these have a special name. This is a special set of numbers, and it's called a Pythagorean triple. Okay, I tried to type this information in up here, but a Pythagorean triple is 3 whole numbers that make the sides of a right triangle and work in the Pythagorean theorem equation. So our first example of a Pythagorean triple is 3, 4, 5. Okay, here's another example of a triangle that is right. And again, I know it's right because of this symbol right here. This square in the corner tells me it's a right triangle. The legs are 12 and 5, and the length of the hypotenuse is 13. So I'm going to write down this information, organize it, so I can say that A equals 5, B equals 12, and C equals 13. So I can write down A squared plus B squared equals C squared. Put the numbers into the equation. A is 5, B is 12, C is 13. 5 squared is 25, 12 squared is 144, 13 squared is 169, 25 plus 144 is 169 equals 169. So again, these 3 numbers, they work in the Pythagorean theorem equation. And these 3 numbers are whole. And when we have 3 numbers like this that work in the Pythagorean theorem and they're whole, I have this note up here again. We call that a Pythagorean triple. Is 3 whole numbers that make the sides of a right triangle and work in the Pythagorean theorem equation. So a typical Pythagorean theorem problem will give you 2 numbers. Look at these 2 examples down below. In this example, we have 2 numbers. We're given a 24 and a 25, and here's a missing number. In this problem, we're given an 8, and we're given a 15, and here's a missing number. So in a typical Pythagorean theorem problem, you're going to be given 2 numbers, and you're going to be asked to calculate the 3rd number using the Pythagorean theorem equation, a squared plus b squared equals c squared. In this problem, we are solving for a leg. You can see that we have the number for one leg, and we have the length of the hypotenuse. And the number that's missing is this leg right here. So one kind of problem you're going to have is you're going to be solving for a leg. And in the other kind of problem, I should probably make these right triangles. In the other kind of problem, you'll be asked to solve for a hypotenuse. That means that you will be given the numbers for each leg, 8 and 15, and they're going to ask you to calculate the length of the hypotenuse, C. All right, here's an example of how to solve for a leg. Let's see, I'm going to write down, the Pythagorean Theorem. It's a squared plus b squared equals c squared. It looks like the unknown is a, so this is going to be a squared. B is 24, so 24 squared. The hypotenuse is 25, so 25 squared. Let's see, a squared plus 24 times 24 is 576 equals 25 times 25 is 625 minus 576 from both sides. And I get a squared equals 49. To continue solving this equation, you want to take the square root of each side, and it looks like this. And what we get for an answer is we get a equals plus or minus 7. But in this case, we only want to use the positive number because it represents a distance or a side length. Those can only be positive. So in this problem, a is equal to 7. Okay, so I figured out the length of the leg by using the Pythagorean theorem. I think that's pretty cool. Okay, here's an example of how to solve for the hypotenuse. First thing I'm going to do is I'm going to write down the Pythagorean theorem. A squared plus b squared equals c squared. And it looks like right here, my legs are 8 and 15, and the hypotenuse is missing. It's c. So I'm going to take this information in the triangle and I'm going to put it into the equation. So we get 8 squared plus 15 squared equals c squared. 8 squared is 64. 15 squared is 225 equals c squared. Let's see, 64 plus 225 is 289 equals c squared. Take the square root of both sides, and you get c equals plus or minus 17. It's important to remember that those square root equations have two answers. But in this situation, negative 17 is an extraneous solution, and positive 17 is the answer that we want for our problem. So the hypotenuse is equal to 17. Wow, that was a lot of hard work to make this video. And I hope that you learned a lot about the Pythagorean theorem. I hope you learned about the legs, the hypotenuse, the equation, Pythagorean triples, how to solve for a hypotenuse, and how to solve for a leg. If you have any questions about how to do any of these things, you can always go back and re-watch the video. Video is going to be pretty convenient. It can answer your questions whenever you have them. I hope you enjoyed the video. Good luck with your assignment.